A long wire lying along the x-axis carries a current of 2 amperes in the positive x direction. There's a uniform magnetic field present given by B is 0.003 I vector plus 0.004 J vector plus 0.002 K vector. So the calculate Y component of the magnetic force acting on the segment of Y length L is equal to 13 centimeters. Okay, so we know the general formula where F is equal I L cross B, right? If that's the case, then we can also know that current in a positive x direction, right? So F is equal 2 amperes multiplied 13 centimeters. So if you convert it into meter, will be 0.13 cross. So we have in a positive x, so it means I vector cross 0.003 I vector plus 0.004 J vector, then plus 0.002 K vector. Okay, now before doing cross multiplication, we know that I cross I gives you 0, right? Or J to J cross J gives you 0 and so on. But however, if you have here, you have I, you have a J, here you have K. Okay, so from there we can know that if you multiply I cross J will give you K vector, but I cross K will give you a negative J vector. Okay, so clockwise multiplication will give you a positive, anti-clockwise will give you a negative. Okay, so that means what we have here, 2 multiplied 0.13, 0.26. Okay, so I times I gives you 0, 0. I times J will give you a K. That means 0.26 multiplied 0.004. It gave us plus 0.04 times 10 to the power of minus 3 K vector. Then I times K will give you a negative J vector, right? So it means negative 2 multiplied 0.413 multiplied 0.002. So that gave us 5.2 times 10 to the power of minus 4 J vector. Now Fy component, so Fy component of the force is negative 5.2 times 10 to the power of minus 4 J vector. Okay, and Fz component is equal 1.04 times 10 to the power of minus 3. Okay, so that's it, I think. So that's answer.